Well, hello friends, welcome back to the show. Today we are going to continue looking at security mitigations, and today we're going to do improved WX XOR X, and that's going to be in the style of the PaX MPROTECT system from Linux. So basically, what we have today is that we don't allow memory to be mapped writable and executable at the same time, but you can map something writable and then later make it executable. And the goal today is to stop that from happening. So we want to enforce some new rules, basically. Memory that has ever been writable can never become executable, and I guess vice versa, that memory that was ever executable can never become writable. So this mitigation would stop one of the exploits I wrote earlier this week, where I was able to inject code into a globally shared library that was used by other running programs, because I was able to take a shared library mapped into my process and remap it as writable and then overwrite the code. So that's just one example of exploitation that would be prevented by this. And then we're going to have to do one exception to this system because our dynamic linker needs to support relocations. And basically, if you load a dynamic library with relocations, that means that after loading it, you have to iterate through a list of relocations and then go and patch some parts of the library you just loaded. So we'll have to load it and then patch those things, and then it needs to be writable while we're patching, right? So, and then after that, it needs to become executable because it's library code. So we need to do an exception for that. But let's start by simply adding some tracking stuff to the kernel VM region object. So region, which is a memory region, currently has these 3 access bits, so read, write, and execute. So I think the easiest thing here would be to simply add has been readable, has been writable, and of course has been executable. So yeah, so we'll put those like in the upper 4 bits of the byte. So this is, let's say, 1 byte. And then we have our, let's see, our bit layout here is, here's readable, writable, and executable. And then we have has been readable, has been writable, has been executable up here. And this makes it pretty easy because then when you set one of these bits, for example, in set readable, it calls set access bit. Oops. So we can simply modify this thing here to also or in the access bit left shifted 4 steps. And then with that, we actually, that thing will be sticky, right? Because we never and it off, we only ever or it in or it on. So yeah, so we'll remember these state of these bits. And then I guess we should have some getters for these bits. So like has been readable. And the readable one is like, I'm not sure if that's interesting for anything. I'm just adding it anyway since it's easy to implement the mechanism that way. Also, like we're using x86 CPUs only in Serenity so far, at least, and x86 doesn't really allow you to control readability of pages. That's something that I wish we had because it would be amazing to have execute only memory, right? Where you could have a piece of code that you couldn't read but you could run. Anyway, x86 doesn't let us do that, so maybe someday. Anyway, so we have these, okay, and then what do we do next? I guess we need to also make sure the initial state set by the constructor takes this stuff into account. So the constructor is here, and when you call the region constructor, you're just passing in access. So I think you're passing in like read or write. So we'll just do a little thing here where we or in the access shifted 4. And maybe just to be on the safe side, we'll also do that. So we make sure that it's only the bottom 3 bits, right? Okay. And then what can we do with this? So this is primarily concerning the mmap and mprotect syscalls. And I guess what we're going to do now is mostly about mprotect, because mmap already stops you from setting writable and executable at the same time. And really the new thing here is going to be adding smarts to mprotect so that mprotect can't be used to move something from writable to executable. So here is sysemprotect, and of course mprotect has 2 sort of code paths that it can go down. Either you are calling it with a base and size that maps to an entire memory region, which is very convenient because then we find a whole region that you're changing the permissions of. We can keep the region as it is and only update the access bits. But you can also call mprotect with a partial region, in which case we may have to split that region into multiple regions in order for the new access bits to only apply to the part that you're specifying. So in either code path, we call validatemapprop to check if this is a valid prot value. So you can see here that it's pretty bare bones. mmapprop is considered valid as long as it's not writable and executable at the same time, or if you are mapping a stack, stack is not allowed to be executable and stack must be both readable and writable. But outside of those checks, we don't validate the prot setting. So let's add some stuff here. So I think if we pass in the region that we are changing, then that would allow us to do additional checks. So if we are having a region, let's see, right, because this is also used in mmap here, but when mmap calls validatemapprop, we don't have a region yet because we're trying to allocate a new region, right? So in that case, there's no existing region that you're changing, so nothing to worry about. But in mprotect, we need to pass in the region that we've found. So either the whole region or the so-called old region. Okay, and maybe we'll update the copyright while we're here. All right, so we have a region, and then if we are trying to, I'm gonna rename these because it's just to make it read a little bit better. So if make writable and region has been executable, then that's a no-no. You're not allowed to do that. Or if make executable and region has been writable, that's also a no-no. Okay, so this is the sort of the basic mechanism, right? Now, if we do this, then the dynamic linker is going to be sad because we'll try to start a program, try to load libc, which has text relocations, and we'll try to make those relocations, but after that, we can't mark it exec. We'll see dynamic linker, CPP 195. We can see here mprotect text. Yeah, so it's trying to mprotect a text segment, prot read, prot write. Prot read prot write. I would have expected it to fail to mark it prot read prot exec. Wait, so what's up with that? Prot write. Let's see, dynamic loader stage 2. So we're failing to map to protect something read write. So this is before we have performed the relocations. Do main relocations. Wait, who calls that? Stage. Oh, we call that at the end. Oh, so this is before we make the relocations. Oh, yeah, right, because when we originally map the text segment, we will map it readable and executable. And that's not going to work. So in load program headers, where we load the text segment here. So currently, when we're calling mmap for the text segment, and we are simply passing in the mmap_prot from the elf header. Yeah, so if we look at the elf header of libc, for example, we can see here that the text segment pt load header is readable and executable. So this is how we'll map it. And then after that, we try to map it read write because we want to do the relocations, but then the kernel says no. So I think maybe the straightforward solution here is to initially map only readable. And then we can add the executable bit later after we have done the relocations. So do main relocations. And then comes stage 3. And previously we would only do mprotect read exec in the case we had relocations, but I think now, since we always originally map them as read, then we can simply always do this. Yeah, because the text segment is always going to be read exec anyway, in practice. Also, this looks weird, so I'm just going to change the order. Okay, so that's a start. Let's see what happens. Of course, now we should still fail to, we should fail here instead of in stage 2 when we're preparing to do relocations. We should now fail after performing relocations, but let's see that that works. Okay, mprotect text prot read prot exec. Now that fails. So, my understanding of what PaX MPROTECT does on Linux is that they make a special exception to this where you can go from read write to read exec once, and only if what you're doing it to is a file-backed piece of memory, so no anonymous memory can do this. So it has to be like an mmapped file, and the file has to be an ELF shared library. That's my understanding of how that works. So I think we can make the same exception, and that seems to work for them, so it'll probably be okay for us. It would be cool if we didn't have to have relocations, but at the moment we have them in libc, so that's unfortunate. I think it might be feasible to get rid of them, and then we wouldn't need this exception at all. But at the moment, let's just deal with the world the way that it is, and our future selves can see if the situation can be improved further. So let's go and try to build out this exception thing in mmap, I guess. So what we want to do now is we want to make a special exception in the case where you're going from writable, you want to make something executable that has been writable. So if should make exception for dynamic loader. I keep calling it dynamic loader and dynamic linker. Like I can't decide which one which one I like. I guess I should pick one. So let's call it dynamic loader. Dynamic loader is the name of the program in userland that performs the dynamic load. So I should just start calling it that. Dynamic linker is a class involved in that, but yeah, that's confusing. Okay, so should we make an exception? If so, return true. And should we make an exception for, let's pass in all of the state we have here. Okay. Make readable, make writable, make executable. Okay, so normally we don't allow RW to RX transitions, but we have to make an exception for the dynamic loader, which needs to do this after performing text relocations. Fix me. Investigate if we could whether we could get rid of all text relocations entirely. Yeah, that would be awesome. Okay, so what are the exceptions here? The exception is only made if all the following criteria is fulfilled. Okay, so first, the region must be writable, trying to become, or must be writable. Let's say, so if region is readable, region is writable, and region is not executable. So if that's not the case, that's no. The region wants to become Rx. Okay, and then it's RW wants to become Rx, sure, and then it has to be backed by a file. So if region VM object has to be an inode, right? Otherwise return false. And backed by a file, or is backed by a file. File is file mapping is private, not shared. Performing relocations in a shared mapping would be very bad, because those relocations are specific to your process, right? So that would be very bad. No relocations in a shared mapping. Yeah. So if region VM object is not a private inode, I guess this could be combined into one check, but it's an inexpensive check anyway, and this makes it sort of more explicit what's going on. So let's stick with this for now. And then it needs to be an elf shared object. So let's just copy out the elf headers from this thing. So like copy from user into header from the region batter as putter size of header. Okay. If that doesn't work, that's a no-no. Then we faulted. Okay, and then let's just run the elf validator, because why not? We have an elf validator, might as well run it on the thing. So elf validate header, file size. I guess we need the inode. Okay, so inode size. Verbose true, that seems fine. At least then it will tell us if validation fails. And then let's check if, wait, the file is a valid elf binary. File is an elf shared object. So if not header, wait, if header what's that called? Type is not et din, then that's a no. Otherwise, let's allow it. And I'm forgetting one thing now. We also only want to do this once, so we don't want to let you do this more than once, because there's no need. And we shouldn't allow this kind of exceptional stuff if it's not necessary. So we have to remember this somehow. Also, let's just say, like, fix me, there are any additional checks, validations we could do here. Yeah, we can leave that fix me. Although I would prefer to fix the one where we don't need text relocations. Let's see. So, okay, so if this succeeds, we have to remember it, and then if we've done this before, then we don't do it again. So maybe we check that the very first thing here. This exception has not been made already. Has not been made for the same region already. If region has made exception for dynamic loader, let's call it executable exception. Yeah, that's a pretty good name, actually. So if we've done it before, we'll say no, and then we just have to remember this. So I think we'll stash it as an access bit. Access has made executable exception for dynamic loader. Now that's a mouthful. And I guess we'll just put it in the very top bit. So right up there. E for exception. That's pretty cool though. And it's nice that it all fits in one byte, because that means that if you clone this region or you split it or something, then we always just preserve the entire access byte. So this will just sort of seamlessly move around with the region, even if you create other regions from it. Yeah. so we don't lose that information, because that would be very bad. And I guess we need some kind of way to set that bit, actually. Has made. Set has made exception for dynamic loader. So first we assert that we haven't already, because that would be very bad, and otherwise we just flipped a bit. Okay. Well, where do we set that bit though? So, I don't want to set it here, because this is, now we're just like checking if this should be okay. So I guess let's add an out param here. So let's see. Did make exception, or is making exception for dynamic loader. So we'll have something like that, and actually we can even do this. That simplifies the malloc call site a bit. Okay, so here, then we'll assert that you have provided this pointer, and then we'll set it to true. And otherwise it'll be false. Okay, so then callers can just provide a Boolean pointer, and we'll use that to sort of hand out the information here that we would like to make an exception for this. So when we call validatemapprop, we'll have something here like is making exception for a dynamic loader. Okay. And yeah, something like that, right? And we'll do the same thing down here. And if the thing is true, then if is making exception, then we set that little flag. Okay. So now we will remember whether we've done this. Yes. So everything boots. That's cool. And I guess let's make a little test program. Oh, we can even make it in Serenity, because why not? Let's see if we can just edit some code here. Oh, okay, that was not healthy. Seems like I didn't work on GUI stuff for a while, and it seems like we have some very, very basic bug here where you can't even delete in the text editor. Yeah, I've been doing security stuff for like 2 weeks or something, so I kind of haven't been monitoring the GUI stuff enough. I need to do some of that as well. It's just this has been so much fun. All right, let's write the test program outside. Yeah, I definitely need to get back to GUI stuff. So let's make a hacks program, even though we're not technically hacksing anything right now. I'm just gonna call it that anyway. Studio. Wait, what do I want to do here even? I guess mman Yeah, okay. So first, let's make something that is writable. So we'll allocate a page and make it prot read, prot write, and map anon, map private, let's say. And let's just assert that it's not failed. And then let's try to mprotect it to become executable. That should not be allowed. So wputter, page size, prot read, prot exec. This should definitely pair. So that should complain. And then we can do the same thing where we make an executable pointer and try to make it writable. Of course, this kind of makes me wonder, what is even the point of anonymous executable memory at this point? Because if we enforce this, then the only thing you can do with anonymous executable memory is map a bunch of zero initialized memory that is executable, but you can never write to it. So it seems to me that maybe we should simply disallow the mapping of anonymous executable memory for now. And if we ever want to build some kind of JIT in the system, then there are a couple of different approaches we can take to that. But like until we get there, maybe it's nicer to just shut this thing out. Also, I used the wrong pointer here, so let me just fix that. So both of these cases should complain, right? And it does. That's very cool. So I think we'll start by committing what we have here. And the dynamic loader change we can actually do that one separately. Because what we're doing is we're simply first mapping dynamic libraries read-only instead of read-execute. And then only once we have performed any relocations if needed, only at that point do we make it executable. So I think that's a fine change to do separately. Livelf map text segments read only at first. Only add permissions. Wait, hold on. To support upcoming WX or X changes in the kernel, the dynamic loader needs to be careful about the order in which permissions are added to dynamic or shared library text segments. We now start by mapping text segments read only, no write, no exec. If relocations are needed, we make them writable. Then finally, for all text segments, we finish by making them read exec. Readable but executable. Rx, yeah. So many different ways you can write this, but that seems fine. And then let's do this kernel change here. So enforce wx or x more strictly, like PaX MPROTECT. So this patch adds enforcement of 2 new rules. Memory that was previously writable cannot become executable. Memory that was previously executable cannot become readable. There is one exception. We sadly, or unfortunately, we have to make an exception for text relocations in the dynamic loader. Since those necessitate writing into a private copy of library code, we allow the dynamic loader, programs to transition from our W to Rx under very specific circumstances, very specific conditions. See, what did we call that function? See, for details, let's say. Or see the implementation of mprotect. Yeah. So I think that's pretty cool. And then let's just stop anonymous memory from ever becoming executable for now, since we don't need it in our system. And then if we ever do want to do something like that, then we can figure something out for it. But I think that's in the meantime, that's pretty sane, because the whole point of what we're doing today is to prevent the introduction of new code into a running program, right? So if you can map some memory at runtime and then put code in there and then jump to that code, that is a problem, and it simplifies exploitation by a large amount. And if you prevent that, then in order to exploit something, you have to jump through several additional hoops, which may complicate or even make impossible exploitation in some cases. But so obviously we need to do this, and let's see about the anonymous executable. So I guess we can just reject it immediately. Validatemapprop. So this guy needs to know also if it's a map anonymous request. So we'll pass that in. Map bool map anonymous. If map anonymous and make executable. Let's just say no. You don't get to be anonymous executable. Because the kernel can still do it for making little trampolines and stuff, but let's not let user space do it. And then we just have to fix that over here as well, right? So in mprotect, whole region is anonymous, right? So now these should totally fail. And the protection really only lets you, okay, so we have, we got problems. What's happening? Wait, malloc is failing? Is malloc asking for executable memory? Say what? 302, assert not reached. Oh, wait, we're trying to do a prot none, and that fails? Say what? Okay, I made some logic mistake, did I? If map anonymous and make executable. Wait, what is prot none? Prot none is 0. So none of these bits are set. So what the frick? Validate. Oh, wait. I put anonymous before stack, not after it. Okay, that was stupid. Okay. Come on now. We're up and we're running, and this program just fails, right? So the first thing succeeds because prot read, prot write, that's perfectly fine. You cannot make it exec. And now we see that we cannot allocate anonymous executable memory at all. I think that makes sense. And yeah, just thinking what other VM object types do we have? So we have anonymous VM object, contiguous VM object, and inode VM object. And contiguous is I don't know if that's relevant because we don't expose that to user space. So from user space perspective, either something is an inode VM object or an anonymous VM object. We don't have anything else exposed, so I think maybe this is fine. Yeah. Okay. This feels reasonable. You know, rip trivial JIT implementation, but I'll take it. And yeah, like I said, if we ever want to do a JIT, when that day comes, we can deal with that then, because there are strategies. You can do multiple mapping, for example, where you have like the same underlying memory mapped in two places. One place is Rx, the other one is RW. Another option is to have two processes where one maps it Rx, the other maps it RW, and then you do IPC to do the JITting. You can JIT to a file and then map the file. There are ways, but it's obviously more cumbersome now, but I think the trade-off is worth it. So disallow mapping anonymous memory as executable. Yeah, this adds another layer of defense against introducing new code into a running process. The only permitted way of doing so is by mapping an open file, mapping an open file with prot read, prot exec. This does make any future JIT implementations slightly more complicated, but I think it's a worthwhile trade-off. at this point. Yeah, so very cool. So I think we're gonna finish up here. So I'm happy with this progress. This would have definitely prevented me from doing the partial M1 map exploit I did last week in the way that I did, because of the lack of this type of protection allowed me to remap a shared library from executable to writable and then mess with it. And then other processes that had mapped that same library were able to jump to that code and then have my compromised version of the code running in their process. So this would be a line of defense against that type of attack. But I could have attacked it in some other way. But at least I think it's good to remove completely these attack vectors. So I'm very happy with it. So this is going to be the end of the video. So if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting here today. I think I'm having a lot of fun showing both the exploitation side and then the mitigation side of system security. So I think I'm learning so much by doing this, and it's so much fun and so interesting to go through these things from both angles and just see where the collision is, right? And security, it doesn't have to be one-sided, right? Like you can come at it from both angles, and that's what I'm trying to do here. So I hope that you enjoy seeing this, and thanks again for hanging out. I will see you next time. Bye.